Hello, welcome to Sir Dave Smarts. In today's video, we shall be looking at angle of elevation and depression. But before we go into solving problems on angle of elevation and depression, we will quickly look at SohCahToa, the mnemonic SohCahToa. This is very crucial in solving problems on angle of elevation and depression. So let's dive right in. The S here represents sine. The C here represents cosine. The T here represents tan. So how do we calculate sine, the sine of an angle? The O represents the opposite, and then the H represents the hypotenuse. The cosine, for cosine, the A represents adjacent, while the H represents hypotenuse as well. Then for tangent, the O represents opposite, and then the adjacent, the A represents the adjacent side. So if you have a right angle triangle, this is your right angle, 90 degrees, and let's say this is our angle of reference. Let's call this A, B, and C. Side BC or line BC is the opposite side, or is the opposite of this angle. Side BC or line BC is the opposite of this angle theta. So this becomes our opposite, while this side becomes our adjacent, and of course the longest side of a right angle triangle is called the hypotenuse. The hypotenuse side is usually the longest side of a right angle triangle. Now, the opposite side and the adjacent side can change. It depends on your angle of reference. So in this right angle triangle, let's use this angle as our reference point. Let's call here A, let's call here B, let's call here C. Now, line AC or side AC becomes the opposite of this angle of reference. So we'll call here the opposite side. The longest side is still the hypotenuse side, and then this other side, line AB, becomes the adjacent. And so the adjacent side and the opposite side can change. It depends on your angle of reference, what angle you're using to solve. But the hypotenuse side is usually the longest side. It's usually the longest side of a right angle triangle. Okay, so how do we know when to use the sine or the cosine or the tangent? This is a problem many students face. So I'll give a few examples and explain. So let's say we have a right angle triangle, and let's call this angle 35 degrees. Let's call this A, B, and C. Let's say line AC is 12 cm, and we are asked to find X, that's line AB. How do we go about solving it? Remember, the angle given to us is 35. So let's see what information we have on this triangle. We have the adjacent side, and then we are asked to find the opposite side. So going through our SohCahToa, Going through our SohCahToa, opposite and adjacent appears here. So it means we will use our tangent to solve. That's the tangent of this angle. So tan theta, which is equal to opposite, that's x over adjacent, which is line AC, where our theta is 35 degrees. That means tan 35 is equal to x over line AC is what? 12. So x becomes cross multiply 12 times tan 35. So that will give us 8.40 cm. Now let's quickly look at another example. So we have, let's call this 60 degrees, ABC. Let's call this 13, and let's call this X. These two triangles are similar. So without wasting time, we're going to make use of our tangent, because opposite and adjacent, tan 60 is equal to opposite x over adjacent 13. X is equal to cross multiply 13 times tan 60. X equal to 22.52. Now let's come back to this triangle. Assuming we are asked to find side P, that is line BC, which of these are we going to use? Is it the sine, the cosine, or the tangent? So let's see. Our angle of reference is 35. So we have the adjacent side given to us, and then side P is the hypotenuse side. So which of these has adjacent and hypotenuse? Is the cosine, adjacent over hypotenuse. So to solve P, we'll quickly do cos 35 is equal to adjacent, which is 12, over hypotenuse, which is P. Now P becomes cross multiply and divide. P becomes 12 divided by cos 35. That will give us 14.65. 14.65. So let's solve one more example. In this example, we'll be looking for the angle itself. Let's call this 5, let's call this 3. A, B, C. We'll be looking for this angle X. So this is the opposite of this angle, and this is the hypotenuse of this angle. So let's see. Opposite and hypotenuse talks about sine. So sine X is equal to 3 over 5 . sine x is equal to 0.6. Now x becomes the sine inverse of 0.6. The sine inverse of that will give us 36.87 degrees. Now, we could also use the cosine and the tangent to find our angle x if the three sides of this right angle triangle is complete. So of course this is 4 from Pythagoras theorem. So let's see, using cosine, cos x is equal to adjacent, that's 4 over hypotenuse, which is 5, cos x is equal to 0.8, and then x will give us the cos inverse as arc cos 0.8. X is equal to the same 36.87 degrees. So you'll get the same value even if you use the tangent of x. So let's solve. Tan x is equal to, the opposite of this is 3, and then the adjacent is 4. That's opposite over adjacent. Tan. So tan x is equal to 0.75 and then x will give us tan inverse of 0.75. X will be equal to 36.87 degrees. So that's how we know when to use either the sine or the cosine or the tangent of an angle given to us. Please go over this video and try your hands on several other examples or exercises.